Good morning, everyone. This is Eli Troyer with AgriDry. I'm going to do the presentation this morning, a webinar on freezing grain is our subject this morning. So we're going to go through and kind of show why you want to freeze, why you don't need to freeze, or why you don't want to freeze the grain in the bin, because it can create some real problems for you if you don't have the ability to monitor and control what happens in the bin. You can get yourself in big trouble. So we want to make sure that we don't create those issues inside the bin. So if we have the next slide. This is the 20th of January 2016. The subject again is freezing grain, moisture migration, and condensation within the grain bin itself. This AgriDry LLC. Presenters are myself, Eli Troyer, the owner of AgriDry, and then I'm going to have several slides I'm going to go through here to show some points, and we're going to have a recorded topic of the week, which is freezing grain that Clint Walker did some time ago. So we're going to have it, and then I'm going to come back on the PowerPoint slides and then follow up after the PowerPoint or the video presentation that's recorded by Clint Walker. Next slide. So this is what happens in a grain bin. It happens way too many times. This either can be caused by maybe freezing the grain at one point in time had something to do with this, maybe not. It's a combination of factors that will create these kinds of problems in grain bins. But when you have these conditions in your bin, you have got probably, other than losing money and spoiling grain, you plug up your unloading system, you can't unload the grain. Guys get in the bin and they try to unplug the unloading system and they get problems, and the problems they start there, but they don't end there. So next slide, please. This is an extreme condition in a bin. Again, I have no idea if freezing had anything to do with this. It looks like it might have been, or maybe just not running air through the grain at all, and the grain heated up and went out of condition. So you can see the grain stuck to the wall, and whatever was able to flow around or out of the bin and left a big monument in the middle of the bin. So that's, again, those are things that you want to avoid in the grain bins, and it's hard to believe, but those kinds of conditions can and do exist in bins, and it's dangerous, and there's a lot of issues with that can cause that freezing. It could be one of them. So next slide. So the topic of the week here, if you click on this link, it'll go to YouTube, and the video will come up, and I'll come back after this is over.
Hello everyone, and welcome to the AgriDry series Grain Quality Control Topic of the Week. My name is Clint Walker, and today's topic is the recommendations and effects of freezing grain. When steel grain bin storage became available in the early 1900s, the bins were only 12 feet in diameter and stored only small amounts of grain. To help maintain quality during the winter months, many grain handlers froze the grain throughout the bin, which, to be honest, was a secure method to increase shelf life of the grain. Just like in a freezer in your home, it was able to hold the valuable product for a longer period of time until the bin became empty. And still, to this day, this method is favorable for dry grain if there's no way to monitor the grain inside the bin. However, this theory has changed for many grain handlers to maximize their profits. Freezing grain is costly and dangerous. Excessive fan run time to achieve the frozen grain temperatures increases electrical cost. The risk of having frozen grain columns throughout the bin can cause unloading issues as well. When the outside temperature begins to warm in the spring or summer, the temperature differential between the grain temperature and the outside temperature can cause condensation issues on the sidewall or the top of the bin, which leads to spoiled or crusted grain. As grain bins get larger with increased bushels, grain handlers are storing the grain for a longer period of time. The need for monitoring this equipment is a must. AgriDry reads Type T thermocouple cables in our bullseye controller. Always knowing what the grain temperature is throughout the bin helps maintain quality and ensures the temperature front has moved through the entire bin. We typically read 6 sensors per temperature cable, with sensors evenly spaced from the bottom of the bin to the top. Sensor spacing and cable lengths are sized appropriately for each bin. We have the ability to read up to 4 temperature cables into the controller for a total of 24 sensors. The grain temperature is displayed on the controller consisting of 6 sensors per page, which you can select with an X for sensors that are only in the grain. You set up a target temperature window, and the controller will gradually lower or raise the grain temperature to the target window and will maintain that temperature until the settings are changed. AgriDry also controls the fans in the grain bin, in which we can assure that the fans do not operate during the freezing conditions. The minimum air temperature setting on the controller is typically set at 35 degrees for aeration and natural air drying and prevents fans from operating below this temperature. When natural air drying grain, the grain temperature should never go below freezing. The moisture inside the grain cannot escape if it is frozen inside the kernel. With the grain temperature always above freezing, natural air drying can be completed immediately as soon as the outside temperature are consistently above freezing. If the grain moisture is high and the number of drying days are limited, the minimum air temperature setting can be set down to 30 to 32 degrees to capture more fan run time. This can only be done if the outside air temperature goes below freezing for short periods of time. If you notice on the chart for the corn, it gives us estimated storage days for certain moistures and different temperatures. As you can see, dropping the grain temperature or moisture greatly increases the storage life of the grain. The allowable times are cumulative, meaning if half of the storage life is used up while at certain moisture and temperature, when the grain drops in moisture or temperature, only half the storage life of that number is available. In conclusion, the equipment that AgriDry offers increases your profits by monitoring your investment and operating the fans when it's beneficial for the grain. Thank you for joining AgriDry's Grain Quality Control Topic of the Week.
It is worth repeating, not freezing grain is only one element that can cause grain to go out of condition in the bin. Uneven airflow through the grain is another reason. You have danger of freezing because you'll have pockets. Air always takes a path of least resistance, so you will have areas in the bin that the air can't get through because of fines not being evenly distributed throughout the bin. To keep the grain in condition, you have to be able to control the temperature of all of the grain in the bin, not just parts of it. Again, air takes a path of least resistance, and that's once you get the grain put in the bin, and we have some solutions here that will help you to do that. So this is what happens when you put grain in the bin. If you want to keep it in condition, you have to be able to control the temperature of the grain. Otherwise, you will get condensation. You'll get all kinds of stuff, and I'll go through some of these slides. And I'll kind of show you kind of a recap as far as why things happen in the bin the way they do, and that's the problem and what the solution is. And we have solutions. So if I can have the next slide, please. So why grain spoils in the bin? In a typical bin, there are spots that will never get any air through them, either, again, because of accumulation of fines. And I'm repeating what I'm emphasizing here with this webinar this morning, because this is very, very important, because it's complicated, but if a lot of people don't understand or don't have the equipment to be able to properly monitor and control what goes on in the bin. So I'm pointing out and repeating what the problems are, what causes the problem, I guess would be the right way to do it. So you have an accumulation of fines. You have a wrong size fans. They can either be too small or too large. And when I say fans can be too large, then simply, in most cases, if 3 fans are good, 4 would be better. If fan sizing on any bin is not all bigger is not always better, because static pressure that's created by the fan, back pressure on the fans, once you reach a certain point with airflow going through the grain, because the thing that affects your static pressure, there's 2 items. One is your depth of grain you're trying to move, and the volume of air you're trying to move through that depth of grain. So you increase the depth of grain or the amount of air you're trying to push through that depth, then your static pressure goes up or goes down according. Now, what we try to do, or what you want to do, is to maintain your fan efficiency by having the fan operating in its sweet spot. So if you increase your airflow, trying to push more air through that bin, you create more resistance coming through the grain, and then your CFMs per horsepower start to deteriorate, and you won't get as much air through it. In some cases, and I've had cases where 4 fans on a bin, static pressure was, and turned 1 fan off, static pressure dropped enough under the plenum of the bin that 3 fans put out more air than 4 fans did, simply because of static pressure. So when we say too large a fan, that's serious, and more is not better, because you create more static pressure and you stall those out. Inadequate roof vent spacing and sizes. is another item. So if you can't get the air out the top of the bin because of roof vents, either not enough vents or they're inadequately spaced. Spacing meaning putting some in the peak of the roof or close to the peak, because when you trap warm air in the peak of the roof, you create condensation, and that causes problems too. So you want to have enough square foot of opening in the roof, and then have them spaced so that you would have uneven or even air coming out of the top of the bin, because again, air takes the path of the least resistance, and if you have the vents located in the wrong area or don't have any in the right or evenly distributed across the top of the roof, then you're going to get uneven airflow coming out of the top of the bin as well. Filling a bin too full can block roof vents. Again, you're channeling air, so if you fill it too full, that air can't get out or can't travel toward the vents, which will make it trouble for you too. Fans are not run enough, or they run too much. So how do you run your fans? So the operator may have no plan on when to run the fans, or does not understand the principles of grain storage. So let's go to your next slide, please. So condensation moisture is a serious problem, and this is where, let's go back, condensation moisture. So wide outside temperature swings can create condensation in the bin, and that's where temperature differential of more than 15 degrees Fahrenheit, potential condensation in the grain mass. If you look off to the left-hand side of the screen, there's a glass of ice water and the condensation on that side of that glass. So we can all relate to that, because we get a glass of ice water, set it in the room, you've got cold inside and warm outside, and it condenses. The same thing can happen in the grain bin when you put warm air across cold grain, or cold air across, and if you have more than 10 or 15 degree temperature differential, and that varies some depending on the relative humidity of the air, how many degrees it would actually allow before the moisture condenses moisture. When you condense that moisture on the outside of that glass on the surface of the grain, you're re-wetting grain, and that's where crusting starts. Next slide. And again, condensation moisture. So running the fans with a wide outside temperature swings can create condensation. And again, the differential of more than 15 degrees Fahrenheit creates potential condensation in the grain mass. So an AgriDry bullseye controller helps to manage that problem, because we set high and low parameters and don't run the fans in extreme high temperatures or extreme low temperatures, or when we're more than, let's say, 15 or 20 degrees away from the grain temperature itself with the outside air temperature, and then we eliminate condensation occurring inside the grain mass. Next slide. So this shows moisture migration in the bin. We've all seen these charts. These were created years ago, and they've been around forever. So what that first picture illustrates on the left would be a bin full of warm grain with cold outside air temperature. So warm air rises and cold air goes down. So if you look at the arrows in the bin, center of the bin, the air is going up. Well, the outside air is colder, so the top surface of that grain is cold, and you're pushing warm air up through the center of the bin, because heat rises on its own. This is without running the fan. This is just the fan being off, and the air actually going into the fan, creating a chimney effect through the bin. Now, if you block your fans or have dampers on your fans or shutters where you don't get free air going up through the bin, then you can avoid a lot of this. But if you look at a fan, sometimes you walk by a fan by the bin without a damper or a shutter on it, and the fan's turning, just the air going through it. Well, that's what's happening in the bin potentially when you have free air going up through the bin. So what happens is, so what you want to do is block your fan so you don't get the chimney effect going up through the bin. The one on the right would show if you have cold grain in the bin and warm air outside, it's to the reverse of that. Your warm air goes up the outside, cold air goes down the center, and then when that cold air hits and your high moisture zone or re-wetting will happen in the bottom of the bin instead of on top. And this can be avoided with, like I said, dampers or shutters on your fans is one, and then running let the controller run the fans. This stuff temperature will be uniform across there, so you won't have the moisture migration with the correctly operated monitor aeration controller that we have with the bullseye controller. Next screen, please. So moisture in the grain is water. This is kind of simplifying what the problem is in the bin, but water turns into ice when the temperature gets below 32 degrees Fahrenheit. So grain temperature below 32, degrees is not the main problem. The main problem is, again, condensation on the grain caused by cooling more than 15 degrees Fahrenheit at one time. Condensation turns into ice and crusting occurs. Air will not flow through crusted grain or ice, and then when you go down thaw frozen grain, it's like taking a chunk of meat out of the freezer and putting it on the counter in the kitchen and waiting for it on thawing. You create condensation on the surface, and then re-wetting of the grain occurs. But imagine that chunk of meat that you took out of the freezer being a chunk of grain in the grain bin, and that's a disaster when you get those kind of condensation issues on the grain kernels themselves inside the bin. So the freezing part, and I'll get the next slide here, I think I'll cover that just a little bit too. So it doesn't hurt to freeze the grain, but it's not necessary. And then there's safety in freezing grain, and the fact it's like taking food and putting it in the freezer. You don't get it below freezing, you don't have to worry about it. But if you have the condensation issues, then that creates other problems. So grain can be safely stored in the wintertime at 35 degrees Fahrenheit. So and it's not necessary anywhere in the country to get grain temperature below freezing. It doesn't hurt to freeze it, but it's not necessary. Again, the problem is with condensation moisture on the kernel itself. Next slide. So how do we keep grain without freezing it? So first off, spreading the grain for uniform airflow while filling the bin. We have a grain spreader that AgriDry manufactures and sells, and we use that will spread the fines throughout the bin so you have more uniform airflow. And then monitoring the grain temperature with sensors in the bin, which is your temperature cable system, and an operating aeration system within the correct parameters. So what we have is we set limits within the bullseye controller system to not run the fans when we have extreme temperature differentials between the grain in the bin and outside air temperature. We also set the target moistures when we do run the fan, that we select the right humidity of air going through the grain so that we don't re-wet or over-dry the grain using high or low humidity. So basically, we eliminate high and low temperatures, high low humidity, and then compare the temperature of the grain of the sensors in the bin to the air that we're trying to move through that grain. And once we get the grain temperature, keep it within that 15-degree temperature differential, we can turn the fans on and turn them off successfully and not create those kinds of situations in the bin. Whereas without a controller, without sensors, we're told turn the fans on and never turn them off till that front is all the way through the bin. And that's the correct way to do it without sensors, without a controller. But once we get the temperature with the controller within the parameters of where we want the temperature to be, wintertime storage, 35 degrees would be our target. Our window would be set 30 to 40. So if our grain temperature is between 30 and 40 degrees, it's where we want it to be. So if we warm up in the spring in the northern part of the country where we have colder temperatures, then we move it. The springtime target temperature would be 45 degrees. So we're increasing or raising the temperature of that grain 10 degrees, and we've got the controller set with parameters that won't let the fans run when we have those conditions that can create that condensation. And then with that, we can selectively pick the air that is beneficial to warming up the grain, and we can successfully turn those fans on and turn them off and only capture the air that we want that's beneficial for the grain that's in the bin. And that saves a lot of money on electrical costs, is one, because we're not running fans when they are not beneficial to the grain in the bin for them to run. We're not creating the condensation issues within the grain mass and creating the problems that crusting and that type of stuff that happens in those grain bins. So AgriDry has grain quality control solutions that will help. Go back to that slide. I can finish that other one before we get to this one. Thank you. It will help to be safer and more profitable in your grain operation. And safety is a huge, huge issue. This next slide, I want to share this with you guys. You're all familiar with this. So what happens when grain goes out of condition? This statistics are from Purdue University, and this is several years old. There's been more fatalities since this one, but what this is saying is in the past 50 years, more than 900 cases of grain engulfment have been reported with the fatality rate of 62%, according to researchers at Purdue University. In 2010, at least 26 U.S. workers were killed in grain engulfments, the highest number on record. And this data here, it was probably 3 years ago. It was published, and I've seen it several times, and this is not counting the last 3 years or so, but in those years like this year, we have bins chock full of grain, and the management part of that grain in those storage bins and creating those kinds of issues, these numbers, we're losing as many or more people every year than going back with these records, and that's totally unacceptable from a safety standpoint. And I mean, loss of life is more valuable than the loss of money in any business. But with the properly monitoring and maintaining the grain in the bin, you manage to shrink, so you're not losing money, and that's important, but the loss of life is even more important. So this all ties together, and the bigger these bins get, the bigger the problems are in these bins. But the solutions that we offer with AgriDry, with what we use with our grain spreader and monitoring, controlling those fans, it completely changes the whole environment inside those grain bins. Next slide, please. Again, this is what happens. This is the picture we showed earlier, crusting, and I mean, that's a disaster in the grain bin, and you got to break up those chunks, get them out of there somehow, and that requires manpower getting in the bin typically to eliminate the problem. Next slide, please. Again, this is the monument in the bin that you want to avoid. I've never personally seen one this big, but I've seen stuff that looks similar to this in bins, and it's no fun. It's just plain there's no fun. Any of this isn't. So next slide, please. So this would show with the EMC calculator, basically the air temperature of the air, take 40-degree outside air, 60% relative humidity, and if you look at the dew point, 32 degrees. So what that's telling me that if I take 40-degree temperature air that's got 60% relative humidity in it and cool that air down to 32 degrees, that air's got all the moisture it can hold, and it's going, so it reaches the dew point. So if you think about the daytime when it's warm outside and it cools down at night, so the air will cool down, the humidity goes up, and all at once the air can't hold the moisture, so it dumps the dew on the ground or on the grass. That's what we're talking about as far as the condensation issues. But this would show that they only at 40-degree Fahrenheit outside air temperature and 60% relative humidity, you only have to drop that air temperature 8 degrees, not 15, 8 degrees, and that air reaches the dew point, and that's where you start to accumulate moisture, the dew on the grass or the dew on the surface of the kernels of the corn or the grain that's in the bin. Next slide. So this shows 50-degree air temperature and 70% relative humidity, and if we drop the temperature from 50 degrees down to 43, that's only 7 degrees that air reaches the dew point, and that's half of 15. Now the dew point itself, if you go extremely over, the farther over you go, the worse it gets, because that air can't hold that moisture. When you cool it down, it just drops it out into the atmosphere. And in this case, the atmosphere is the grain itself where the air is going through, running through the system. Next slide, please. This is an example here. We got 65-degree outside air temperature, and I keep repeating this because this is serious stuff in grain bins that can be avoided. And by avoiding this, we can avoid crusting, we can maintain grain quality, it just goes on and on from there. Safety, profitability in your grain operation. So if you have 35-degree grain in the bin and run 65-degree air temperature through it, you're going to potentially create in that bin what you see with that glass of water on the right. You've got colder inside and warmer outside, and condensation occurs. Again, the outside of that glass would be the grain inside your bin, and you're dumping moisture back into that grain by cooling it down way past the dew point temperature. Next slide. So what is the solution? So grain in the bin is money in the bank. That's we've got $3.60 corn in bins in the U.S. right now. Soybeans are down. Grain prices are half what they were 3-4 years ago. But $3.50 corn is still money in the bank. And if this was money in the bank, you need to manage. So that's where. What is the solution? Here's the solution. So let's go to the next slide. So it's a risk management thing. So what we have here is you manage your grain like you manage your money. So how do I do that? Well, you know what condition it's in, and this is moisture and temperature of the grain in your grain bin. They control what you can, and basically operating the fans under the right conditions to avoid the Go back to the condensation. Freezing is part of it, and condensation is the bigger part of it. So, and the other thing is and just like your money in the bank, you manage your risk, because you wouldn't put it somewhere where you're going to lose it, and that's a topic for another whole webinar on managing that. But we have grain in the bin that equates to money. We can relate to that, so you know what environment grain will thrive and increase in value, just like your money. So you want to create the environment in that grain bin. It's a combination of moisture and temperature, and if you can manage those in the grain bin and keep them within the parameters, you get the shelf life of that grain, that you can keep it for a long period of time and without deteriorating, just like your money in the bank. It's the same kind of deal. There's enough science behind grain management, the grain management itself, knowing what to do in the bin, and then we have some technology that we as a company provide for you to be able to manage your grain in your bin. Hire someone to help you manage your grain. That's what we do as a company. We work with the end users, and if you own our equipment already, which most of you, I believe, probably do, we're doing customer training meetings. I just did one yesterday and one on Monday in Mississippi, and did one in Memphis, Tennessee on last Friday. We had growers come in and dealers that sell our equipment to help the end user better understand the grain management part, and then applying the technology with our equipment to that. And that you've already invested the money in these controllers, and if we can help you better understand, better apply what we're using here, that's money in your bank, and that's what we offer as a company to you as our customers. Next slide. Again, there's money. What's in those bins is money in the bank, and that's so you need to watch and take care of it, just like you would cash money or in bank accounts or what other investments you make wherever you put your resources. So next slide, please. So AgriDry, our website is agridryllc.com. We're available with tools and experience to help you work safer. First off, safety is always first, and then be more profitable in your grain operation. This webinar contains information to help you be safer and profitable. We have seminars scheduled throughout the grain producing areas. For the schedule, go to our website, agridryllc.com. They're posted on our homepage. Some of you found our information there. Call in to be invited to the webinars, which we're doing, and I assure you we'll practice and get this right. So when you log in, that you're not waiting. Well, we're practicing, but we're learning as we're going as well. So again, I apologize, and I appreciate your patience with this. So, and we will come to your location and work directly with you. We're working through dealers. We work direct with end users, trying to work mostly through dealers, because we need more people locally available that understand the technology to be able to help you guys get better experience with the equipment that we provide. We will work and train you directly from us or through our dealers. And it is all about education and applying technology to your grain operation. So in a nutshell, we have the tools and the technology and the experience that we can help you hire us if you need to, and that's what we offer ourselves to you. When you buy the equipment from us, you get us as part of the deal. So it's not necessarily buying the cheapest you can buy, but getting the customer service with the end user is the important part of any invested equipment that we have here, and that's our experience. So when we get the right equipment installed correctly and train the end user on how to use it, it works every time. And we know the solutions. We've got experience with this. We've got a lot to offer you guys, and that's what we're here for. So next slide, please. Thank you for your attendance. Again, my email address is etroyer@agridryllc.com. My cell phone number is on there, 419-630-6449. Our website is agridryllc.com. There's a lot of information there. We have tech support people in the office that take the call, call the number that's on your controller when it's 855-AgriDry or 419-459-4399. The tech support people in the office are there to help you, and with AD Link, which is a web-enabled device that we use. Some of you guys have that, some of you don't. With AD Link, we can update any controller that's already out there that does not have AD Link on it, so that we can log into the data on your controller. You can do it from check your settings, change your settings from your cell phone, from your computer, from anywhere in the world, any web-enabled device. And if you don't have that on your controllers already, we can add that to it and upgrade that, and makes it easier for us to access, for you to access, for us to train, work with you. And with all that said, so work safe and be profitable. And that's the end of my presentation here. So if we have open discussion here, I'll turn it over to Glenn, and he can, or Megan, whoever's got control of this, and take it from there. So I'll be standing by. Thank you.